Greetings, fellow explorers. This is Tony with Fount Systems Network, and we are here in pursuit of low-carbon innovations for industrial wastewater treatment. Today, I'm in conversation with Mark Hayes. Mark is a water expert, he's a fellow inventor, and he's a hydrologist. Mark spent 6 years as the Chief Science Officer with Psionics, which is a publicly traded water services and equipment supply company. Today, Mark is going to share his insights and his expertise on a water characterization study, which I obtained earlier this year from the Piney Point phosphogypsum stack. You all might remember a prior episode that I did where we looked at the Piney Point Wastewater Emergency from just a couple months ago. Mark and I take a deep dive here into the contaminants present in the wastewater at Piney Point. We brainstorm on some ideas for a business approach to managing wastewater volumes while at the same time mining that wastewater for valuable minerals. We get into the possibilities also for lithium and rare earth elements, and while they don't show up in the water characterization study, they weren't measuring for them either. Mark suggests here that geological conditions could likely support the presence of these valuable minerals. Finally, we talk about radium-226. While it is present, we're going to look at whether it's as big a problem as some people have been suggesting. Stay tuned, fellow explorers, for an engaging and educational discussion on Piney Point wastewater.
I wanted to look at the water quality tests, the water characterization studies from Piney Point. And I know you got a chance to peek at that. I thought maybe the bulk of our conversation today, we could just kind of go down that and just like let you talk about what you see on there, and then I don't know, go from there. Just be kind of spontaneous about it.
Well, that's fine. What I saw was incomplete testing.
Okay.
Because I looked up some of these things from those phosphogypsum mining operations.
Mm-hmm.
And this is basically, the test results you sent me were basically for drinking water. I mean, these are the EPA's drinking water test parameters. You look at it and your TDS is basically 29,000 milligrams per liter.
Mm-hmm.
Okay. That is slightly more than seawater is. That there isn't that big of a deal.
Mm-hmm.
And your TSS, which is your suspended solids, is 28,
mm-hmm.
which, depending on where you live, you could have that coming out of your well water all by itself.
Right. So this 4.93 pH, it's slightly acidic. Is it safe to assume that this wastewater is slightly acidic because it's left over from the phosphoric acid manufacturing process? I know they're mixing phosphite with sulfuric acid to get the phosphoric acid, which is the product. Do you think that pH is just a result? It's just all that leftover sulfuric acid in the wastewater?
It's actually, the sulfuric acid number is fairly high.
Mm-hmm.
I mean, the SO4 mm-hmm. coming out of there is, 16,000.
Right.
So yes, that is definitely the result of that. But one thing that did catch my eye
mm-hmm.
was the amount of phosphates going into being discharged. I mean, 130 milligrams for phosphorus going into a water body is kind of high.
Yes. Yeah. I think it's interesting. There's phosphorus left over at the end of the phosphate mining process. It's almost like this is kind of just left over, or it's some kind of inefficiency that's happening at the plant and it ends up in the wastewater maybe.
Well, now you got to look at it as the whole picture though, Tony.
Mm-hmm.
We're looking at orthophosphate, total phosphorus. Okay. It's the same number. So
okay.
It's the same source.
Mm-hmm.
Now, if you go up and look at your calcium number,
mm-hmm.
you'll find that calcium is 1 point, well, what is it here?
307.
307.
Mm-hmm.
You add calcium and phosphorus together and you get calcium phosphate.
Okay.
That's, and what are we mining? Phosphogypsum. So, I mean, this is dissolved calcium phosphate in the waste stream.
And then one thing I've learned in doing my own water quality testing on my water purification device, you test for the thing that you're looking for, and if you don't test for a thing, then you're not going to detect it. And so that's getting at some of the rare earth metals that you're looking for, that you suspect are there, but they're not tested for, I think.
Like, things that aren't tested, I would be very interested in seeing how much lithium there is, how much strontium and yttrium and the lanthanide series. These are your rare earth elements. If those have a higher concentration, those might be worth hydromining.
Yeah, I don't really have a sense of what items in here that exist in high enough concentrations and might also have a marketable value if you get into brine mining. Like I see higher quantities for arsenic, calcium, and these are relative terms. Like, so for the arsenic just now, I see the 52.5, but the units it looks like that's micrograms. So there's almost none there. But the calcium, you got 316 milligrams a liter. Magnesium.
And all these are,
yeah.
And magnesium's measured in milligrams. I mean, and honestly, magnesium is fairly worthless. Manganese, however, is worth a lot, but again, it's micrograms.
Right.
Molybdenum is worth something, but again, there's nothing there. Copper is almost non-existent. Cobalt is worth something, but again, not much.
Right.
Beryllium's worth a fortune, but it's not even 1 unit on the microgram scale even.
Right. I'm almost wondering if there isn't, like you have the phosphogypsum company, and there's a way to develop a business-to-business relationship, kind of a symbiotic relationship where you kind of plug in a system within their manufacturing operation, almost as a sub-operation, while they're active and operational, as a way of harvesting these secondary ones, kind of like the way this guy that was harvesting these natural gas flares was doing.
Well, that's going to require proving to the companies that are doing the initial mining that this is good for them.
Good for them.
And I wish you the best of luck. I really do.
I think one of the issues they have, and I need to learn more about this, I think one of the issues they have is just managing volumes of wastewater. What happens, they engineer these, the gypsum stacks to be a certain size and have a certain capacity to have a volume of wastewater plus rainwater that comes in there. And I think it can be problematic for them during very rainy seasons to manage the volumes of wastewater that get impounded along with all that rainwater that seasonally accumulates. And I think that's part of the reason that they get breaches in these phosphogypsum stacks, is because the volumes of water in there become unmanageable. So I don't know if there's a business case in that, but it's certainly a liability or a risk reduction.
Well,
if you can just manage volumes of wastewater, and in the process, harvest stuff from the waste stream in the process.
Well, if all you're looking at is managing water levels in a basin, 2 ISO containers can do that worth of water purification equipment. And basically the clean water goes out to wherever,
The
river, the bay, the ocean, whatever. And the concentrate goes right back into the basin. And like I said, the papers indicate that there is usually a fair amount of lithium in these waste streams. So if one could harvest the lithium, you'd probably have a profit stream right there.
That's a super interesting idea. I get this water characterization study and I just look at what's there. And then now here you're reminding me they're only detecting what they're testing for. So there's other stuff that we should look for. These concentrations, I mean, this is below a drinking water standard. I mean, if I'm reading the EPA's drinking water standard, I mean, they're talking about, I looked this up, this EPA rule on drinking water, you can have up to 5 picocuries per liter of radium.
Yep.
And this sample actually has 0.3.
Now, the other thing is that the radium is low here.
Mm-hmm.
You go to the next mine, the radium count might be much higher.
Mm-hmm.
So really, this entire radiological part of it, unless some of these other dates show a horrible increase, which can also happen.
Mm-hmm.
I mean, a continuous mining operation, these numbers change,
mm-hmm.
but the ones I'm looking at right now give me no concern whatsoever. Well, honestly, if you want the truth, I found those water quality tests to be kind of boring. I was expecting something to jump out at me. And I'm like, okay, well, other than the sulfates and a couple of other things, this doesn't look much different than like groundwater tests from the southwest part of the United States. I mean, there's a lot of metals in like the groundwater of Arizona for arsenic and aluminum and a whole bunch of other things.
Mm-hmm.
So I didn't see anything, I'm sorry, that was overly interesting.
Yeah, no, that's fine. I just thought that you would have a really good insight into maybe there's something in there of value that can be accessed. And so I have a little more work to do.
Not with those numbers.
Not with those numbers. It's a pleasure and super educational, and I really appreciate your time. And I look forward to following up with you here.
All right.
All right.
Let me know, Tony.
Will do, Mark. Have a great weekend.
You too. Talk to you later.
Take care. Bye.
Bye.
So that's it, everyone. What did you think? Was it engaging? Was it educational? Do you think there are possibilities for brine mining in and around these phosphogypsum operations in Florida? Let me know what you think in the comments below. If you like what you see here on the Fount Systems Network, please like and subscribe to the channel. Follow us on Twitter. And remember, everyone, keep exploring, keep growing. I'll see you next time.